Hey yo, welcome to Hillbilly Garage. Had some parts come in for a bit of a future project, and I got an idea, something that I wanted to talk about. Uh, you know, bit of an epidemic, I guess, going on about camshaft, hydraulic flat tappet camshaft and lifters failing, and gazillion different theories as to why that is, and I'm not here to try to theorize on anything. Honestly, I don't know. All I know is if we're going to continue to use hydraulic flat tappet, and you know, we're going to have to try to do our very best to try to make sure that we're going to be as successful as possible with break-ins. And got to make sure we use high-zinc oils when we do our break-ins. A lot of speculation on how many RPMs to turn it, how long to turn it. I don't know what all the science is for all that, people. All I know is you got to run it for a pretty good little bit, 20, 25, 30 minutes at off idle, 2,000 RPMs, 2,500. I don't know. You hear it all over the place. We've been successful so far. We do our break in for between 20 and 25 minutes, and we don't let it get below 2,000 RPMs, and we gradually move it up and down, up through to 2,500, down towards 2,000, and we just keep doing that up and down, up and down. The reason for that is camshafts get their oiling on the lobes from splash swing. When the crankshaft is rotating and oil is running everywhere, down block engine is just one giant oil leak, is all it is. And oil is dripping, and the counterweights are slinging, and it's slinging it all up into that valley right there where your camshaft's running, and you're slinging oil. All right, so that's how the lobes get the majority. Well, let's say most of their oiling. Some of it they're getting. The other part of the leak is the lifters. The pressured oil that's in the lifter bores is dripping down and heading through there. So anyway, that's how it gets most of its oil. But for initial break-in, while the surfaces are mating up and getting heat treated and oil soaked, we gotta make sure that there's plenty of lubrication. But there's a key factor, and I know most all y'all know this, but these lifters they have to rotate. I mean, that's just the way that if you just sat in one spot, because these lobes are tapered, one end is higher than the other. We'll get to that in just a minute. But because of that, and the way that the lifter rides on that lobe, it makes it turn as it's working because it's a little bit offset, and the taper works on the outer edge, and it makes the lifter turn continuously. Every time it goes around, it turns eighth to a quarter turn. Just turns, and that's the key. It has to turn. So part of that, there's a couple of three main factors here, and I hope y'all can see this. But when you open up your package, a couple things. If I turn that in the light, are you seeing those shiny lines that look like it's going round and round and round? Mm-hmm. The machining process. All right. When they machine the faces of this lifter is not flat. All right. It is dome shaped. Not anything serious. It's not like you can look at it with your eye and see this great dome. But when you turn it in the light, the way they machine it, you know, they're machining that point or that dome to it, and it creates these lines that make it swirl in the light. All right. Now, the first thing you want to do when you pull these out of the box is, wipe it down, Make sure there's nothing on the faces. Take a couple of them, wipe them down good, and then you put the two bottoms together, and when you wiggle them back and forth, you can feel, and sometimes you can even see that it's not flat. They will rock just a little bit. And then you hold them up to the light like this, and if you get your angle just right, where'd my light go? There it is. Then you can rock them back and forth, and you can watch the mates, the two areas that are mating, moving around in the light. It's not really moving, but it's blocking the light. Right now, for me, it's up at the top because I got the two tops pushed together. Push my thumbs closer together, and now all the light's coming through the top, and the bottom is blocked. So you can, when you put those two surfaces together and you get it lined up, you can see the light shining through, and you can see where they're touching, but they're not touching all the way across the face surface. So you go through the entire box and you grab them just randomly, you clean them, put them together, hold them to the light, feel for the rocking, look for the light. Put one down, grab another. Go through the whole box. Don't just grab 2 by 2 by 2 by 2. Make sure that they all do it to each other. Okay? So that way you're confident that you have a bit of a dome there and not a perfectly flat surface. And you look for those machining marks that make it look like a pinwheel going round and round. All right? So it's not perfect, but that's how we, get a better idea that these lifters have got the proper surface. On an old lifter, you can see that there is a wear ring, that it's a natural occurrence, which means that this lifter was turning in the bore properly the way it's supposed to. Because you have this shiny edge and then you have that duller face in the middle. That's where it doesn't ride, but it rides on this shinier part. So this lifter was doing its deal. It was going round and round. If anybody's ever seen a totally destroyed one, you'll know that it looks nothing like this. It's just total trash, and it's catastrophic. Like I said, these lifters, they were working, all right, but they are to a point where when you hold them up to the light, you can't see any light through them anymore. So they are worn to where they can't be used. All right, but anyway, on to the next step is the lobes. Like I mentioned earlier, they are not perfectly flat across the highest point, or the nose, I believe it's called. I'm not a cam doctor, but anyway, the taper is what causes the lifter to turn, which is how they survive. Now, without any sophisticated equipment, we can still get a good idea as to if we have taper across here. And it's going to be really hard to watch this, but the process is pretty easy. You're just going to take your caliper. I got a digital one that really helps to make a big difference. Got it set on inches and decimals. Okay, I'm going to hold my knob up against the jaws and zero it, because during this process I got my machinist ruler down here because it gives me a solid, smoother surface that my caliper will actually slide on. And I'm going to hold it to one edge of my lobe. I'm going to hold tension on my dial, and I'm going to roll my camshaft just a little bit and watch my numbers over here. They're dropping now, so now I'm going to go back the other direction, and I'm looking for the highest number. It's difficult because you gotta keep the jaws down on your machinist roll so everything stays square. Hold pressure on your knob and roll it through its highest point. It takes some time. You gotta be patient. You gotta make sure you stay square on your lobe, flat on your machinist ruler, and get a good roll. Watch the numbers. All right, I'm seeing 335 on that side, and the numbers, I mean, they're not significant for what we're doing right here because what we're looking for is the difference. Okay, I saw 335 on this side, 365 on this side. Like I said, and I'm not gonna swear by those numbers because we're using a caliper here and my thumb, and I'm a human and I make mistakes. But what I do see is after I roll it back and forth a couple of times, I see that one side is in fact taller than the other side. And something else you got to deal with is if you're using something here, your lobes are going to catch on. It's going to mess you up. But like I said,
can't really see the numbers.
I know, and that, like I said, the exact numbers are not the important part. The important part is the fact that we see a difference from one side to the other. Like I said, we're not looking for a precision measurement here. We're just looking to see what the highest number is on one side, which was 360. Then we go to the other side. And it was 335. Now, like I said, the numbers are going to be different because unless you've got a square cam, you got a couple of exhausts and you got intake, exhaust, intake, exhaust. So whatever the lift is on those particular lobes between exhaust and intake, there's going to be a difference in that high number, but that's not the point. The point is you want to see a differentiation between this side of the lobe and this side of the lobe, and they're not going to follow an exact pattern either. So, but like I said, so don't get hung up on the numbers. Just watch for the biggest number on one side, the biggest number on the other side, and as long as those two biggest numbers are not the same, then that means you've got taper, and that's what we have to have is taper. Okay, so go all the way through it. It's slow, it's painstaking, but you check them all, and that way you can feel confident that you have taper in those lobes, which is another key factor to making sure that this cam is going to survive. If you discover that you have lobes that don't have taper and it's exactly square across, then you need to, before you ever put that in the motor, send it back to the manufacturer or whoever the distributor, whoever you got it from, and tell them there's no taper on that lobes, you want a new one. Okay, and then when the new one comes in, of course, you got to go through the whole process again. But it's a whole lot better to go through this painstaking process than it is to put it in here and find out when you're rebuilding it the next time that something happened to your camshaft. Now, is this the perfection way? No. If you've got a set of machinist V blocks, it's a whole lot easier to do this process, and you can use a magnetic dial indicator and set up and do that way. But whatever process you're going to use or you have access to, which for me, this is me. I got my table, my machine screw, got my caliper. A little bit of time, a little bit of effort. Now, so we've made sure that our lifters, that we feel confident that we have the proper domed face. That would be convex, right? Yes. We have a convex face on our lifters with good machining marks to make a swirl. Then we go through and we check our cam lobes to make sure that we have a differentiation across each side of the nose. And then finally, another key factor that I think gets overlooked is how the lifters actually feel in the bores. Because if the lifter will not float and turn in the bore because there's foreign material in there, dirt, trash, these lifters, in the area where they ride before, they were clean, but just below them there was a oil deposit, carbon deposit built up on the bottom that would not let them come through the bores. And if that would have made its way up into the bore, then it would have prevented it from turning at that point. But I cleaned them. Forgive this block because I just picked it up. It's actually for a future project, something that me and Robert from Boneyard Revivals have discussed. Maybe a little friendly competition build off, but we'll get to that at some point. What we want to do now is we want to make sure that this lifter is going to ride in the bore like it's supposed to. And you can see I'm just barely touching it. And it floats very nicely, smoothly in there. All the way back up, all the way back down. All right, it turns very, very easily. But also give it, a little side to side, little wiggle. Make sure that it doesn't have excessive room in there, because the only thing that you want is that little cushion of oil that's going to live around this thing as oil circulating through and keeping that free. But you can see that lifter, it's riding real nice in that hole. There you go. And with the tip of my finger, I can turn it. Can y'all see that?
Yeah. Wait, keep doing it. Keep doing it. Oh yeah,
Yeah,
you can see it now.
A little bit of brown deposit there, yes. Yeah, I'm just turning that with the tip of my finger. So that lifter is living free in that bore. So we can also feel confident that the clearance and the oil bearing that we'll have in there is going to be sufficient to allow these lifters to turn in the bore. What I suggest you take all 16 of them and pass them through as many holes as, if not all 16, and make sure that no matter where you drop that lifter in, that it can live and survive and twist and turn in every single hole. That way, when it's time to go put this thing together, no matter which one you grab, doesn't matter which hole it goes into. Now remember, after you run it, then it makes a huge difference, and you want to make sure it always goes back in the same hole if you ever have to take it apart. But so those three factors, and of course, when we do the block prep, we are going to make sure that the entire oil galleys are completely clean of all trash deposits and everything else that's not good clean oil, so that when we circulate oil, we're circulating nothing but oil and no trash. The lifters will live free on their little bearing of liquid bearing in their bores. The faces got the right uh, dome to it. The lobes have the right taper to it. And if we adjust them properly and don't try to overspring it, then we should have a successful break-in. And is that a guaranteed fact? No, it's not. But if we do everything that we can do within our power to try to prepare, make sure we use good oil, make sure that we prime this engine before we start it, prime it, turn it, prime it, turn it. We've talked about that before. Make sure that everything is ready to go. We got a good carburetor, distributors dropped in properly, and when we hit the switch, turn the key, whatever it is, she'll fire and she'll run. We can run it up to 2,000 RPMs with our good oil, fluctuate, do our run time. 20, 25 minutes is for me. You want more than that, that's fine. I don't think anyone really suggests anything less than that. But you do your own research. You find out all your details. Take every step that you can take. And we can be successful breaking these cams in. So, while we're thinking about that, y'all wish us luck whenever this project comes up and it's time to break it in. And we appreciate each and every one of you. Please like and subscribe. Keep coming back. Throw them comments because y'all know I love them comments. I really would like to have some more, actually. Because, I want to communicate with everybody. So, talk with us. If you want to visit hillbillygarage1215.biz, go get you Hillbilly Garage t-shirts, stickers, Hillbilly Garage tools. Communicate with us about any engine work that you might have. And we'll see y'all. Bye.